Hello, welcome to part 4, talking about hybrid HVAC and cooling systems. And we left off on part 3 about talking about how battery heating and cooling is no longer just a nice to have, it's a necessity. When this doesn't work, your vehicle doesn't work. So basically customers have to fix it. So again, to recap, these vehicles HVAC can also be used to control high voltage battery temperature, which means the AC compressor or auxiliary heaters can come on even when the AC is off. So AC is off, all of these systems can turn on. And since these systems use the vehicle's HVAC to regulate battery temperature, they're no longer considered optional repairs or maintenance. Just recapping that these kind of customers, I've had them in the shop where it's like, okay, well, I'll get around to fixing it. Well, it's like, no, it's not your normal vehicle. You can't fix it when you feel like it needs to be repaired right now. So you have your, basically as it comes through right here, your inverter up front here is your battery, the charging control module, and then the high voltage battery back here as it's showing this setup. And then basically kind of the gist of it is between the chiller, this is how it cools, and then you have these heaters, which we'll talk about next, but the chiller is what basically runs off the AC refrigerant system. So this AC compressor, which we talked about how it operates high voltage, uses high voltage to turn that arbor, it's going to pump that refrigerant through the system just like a conventional AC circuit. But what happens is it gets down to this, which should look familiar to you. And what do you think that is? Yeah, TXV valve, right? It looks like a thermal expansion valve because it is. You have your high and low side coming in right here, and it goes through the TXV. And normally in the car, in the cabin, it'll go into what? Yep, the evaporator. Well, inside this box is an evaporator. This box is called the chiller. So this refrigerant goes into that evaporator, and now the evaporator is in a box that's surrounded by coolant, and that's what this coolant hose right here goes to the battery of the high voltage vehicle. So that coolant comes in and gets cooled with the evaporator instead of air in the cabin, and it goes to the battery to cool the system. Pretty neat. Works pretty cool. As far as heating goes, right here, these are basically 3 glow plugs. That's all they are, resistive heaters, and they just kind of alternate their angle. So coolant goes through that, hits that glow plug. They're diagnosed similarly, at least on this vehicle. And then as, again, the coolant goes through, it heats up to get to the battery packs. And again, this vehicle has 2 battery packs. So you have the chiller right here. You can go through the heater right here to the battery to adjust to the appropriate temperature, whatever the battery control charge module wants. So it could be on while it's charging, it could be on while the AC's off, totally independent, can be operated at any time the computer deems necessary based on programming. So keep that in mind when diagnosing this and working on it. Again, here's temp sensor and a little valve to operate that loop. Again, remember the loop, it has a little pump, the valve, and it can go through this filter, and it goes through back over here to the battery to keep it cool. So multiple loops. Here's your temp sensors all the way across. Here's the valves. Take a second, you can look at this schematic. Again, I also uploaded the PDF version of this PowerPoint to Canvas, so you can take a look at that. But there's your temp sensors. There's your valves to control all of these loops. So if you do have a leak in one loop, it can't affect the other loop since they share the same reservoir. On a vehicle with 2 separate systems, like the Prius with the engine and its motor electronic cooling system, they're completely separate. So one leak doesn't necessarily affect the other one. Okay, keep this in mind when diagnosing and repairing. So if you repair a part, replace a part, try to lose as little coolant as possible if you're not changing the coolant. And you can do that by pinching off the hoses before and after the component you're changing. Pre-fill that component, hook it up, and lose as little coolant as possible. That extra time is going to save you actually a lot of time. So, but if the vehicle is not water cooled, it's air cooled, like the Honda and those earlier non-plug-in Prius, air coming in is very critical to be clean. It has to be filtered from debris. So always check this if you have an overheat code. So just like the common overheat failure of a liquid-cooled battery is going to be a bad electric water pump, could be a bad electric valve, it could be the chiller system, could be low coolant. Those are the things you're looking at for diagnosing an overheat code on a liquid-cooled system for a battery, and or the inverter. You know, real common faults, overheat fault codes on the inverter. Pretty common to have an electric motor failure on that. You should see turbulence in that degas bottle on the inverter with the vehicle in ready mode. So remember that ready on light indicates the vehicle's the equivalent of key on engine running. So as soon as you turn it on, that electric pump turns on to the inverter cooling system. You should see some type of turbulence in that reservoir for that system. Okay, so back to the air-cooled battery. If it's an air-cooled battery and you're overheating, take a look at the fans, take a look at the filters, make sure they're not plugged with debris, make sure the fan's operating, make sure you have airflow. Again, people put stuff up against on the Honda, that luggage tray, blankets or jackets up there that can block the air coming into the battery, which can cause overheat. People have, like in the Prius, the vents on the side of the seat. You can have oversized jackets or blankets or luggage. Ford has some inlets on the bottom by the feet. So it just depends where the vehicle receives its air to check for blockage. Again, and I've seen luggage and debris in the car actually cause overheat failure. So take a look at that. Here's a Prius one on the side. You can get lint, animal hair, fur, all up in this too. So keep in mind. And then of course the cabin filter can reduce airflow to the HVAC as normal vehicles, as non-hybrid. So take a look at these when diagnosing. Some cars have them, some don't. They come into favor, they fall out of favor based on whoever's designing these vehicles, to tell you the truth. So you can have a cabin filter like this for the HVAC. You can have them for the rear HVAC. You can have them for the battery if it's air cooled. You can have them in the seats for climate controlled seats. These can be numerous and throughout. Some cars have two for the cabin. European cars will commonly have two, one for each side of the dash. So keep that in mind as well. So that basically concludes the hybrid HVAC and cooling system theory and operation. Again, this is just an introduction. I kind of wanted to talk about review items to kind of spark your memory, and also talk a little bit about the nuances. Some of those nuances, again, were how the engine gets up to operating temperature quickly with the coolant control valve, the coolant thermos to keep hot coolant ready at all times to be put into the head to warm up that engine. How do we accommodate and bypass and kind of mitigate the problem with ice turning off at idle stop? How do we keep the passengers comfortable with heated and cooled air? How do we control a battery, either liquid or air? And how do we keep them cool or hot? What components are used? And keep in mind when you're servicing the systems, you want to minimize your loss and use hose clamps on coolant controlled items to minimize that loss. So, and always safety in mind. Make sure the vehicle's depowered. Do your live dead live. Make sure 0 volts coming out of the high voltage battery before you start working on these items. If you have any questions, email me. This basically concludes the lesson for today. Thanks for listening.